So we spoke about live data here. So we're going to go a little bit forward here before we even go and create our room database here class. So the live data here, remember, it is indeed what allows us to attach the data that we're getting from a repository, which is actually we're getting from our DAO class, really. The data we get it, we have to wrap it around this live data so that we can use the capability that we really want for this data to have, which is the capability of connecting or broadcasting that something has changed. It received data inside our view model so that the user interface knows what to do with it. So it has to refresh itself or do whatever it needs to do so that we have this dynamic system working around. So live data is a class that we can actually use right away and wrap our data as we get it. So in this case here, the best candidate will be in our list, right? Because this is where we're getting all no-do. So all of our no-to-do list items that we've added, this is where we're getting everything, selecting everything from database, our table, and retrieve all that stuff. So it is beneficial for us to actually wrap it right here. So I'm going to say live data. So this is actually given to us. Notice live data here allows us to add a type inside, just like a list. So I'm going to put that inside of all of this, like that. So what this does, very simply, so don't get scared of these angular brackets there. So what this means, first of all, we're saying we are literally covering this list of no-do objects inside of live data for obvious reasons that I just explained. All right, very good. So we did that now. That is set. So we are set. We don't have to deal with this anymore. So next, what we're going to do is we're going to go ahead and look at our room database class. Okay, so this is the class that will govern all of these entities, SQLite and DAO. So it's the enclosure, if you will. So room database class is going to be able to dictate along with DAO how to get entities, meaning how to go ahead and look inside of a SQLite, or in this case, how to issue queries. And we are using room database because it will allow us to avoid a lot of user interface performance. Because remember, room doesn't allow you to issue databases queries on the main thread. Because if we have put everything on the main thread, what will happen is that the main thread, which is also where all the things are happening, is going to jam the traffic. So the application becomes irresponsive and ultimately dies. So not a good picture. That's the reason why room database class or layer is very advantageous, because it takes care of all of those interactions that allow us to run things on a thread that it's not the main one. The other thing that room does, it also provides a compile time checks for our SQLite statements that we created inside of our entities and so forth. So it does a lot of good stuff. That's why we're going to make this room an abstract class. All right, let's go back down here. Let's say still under data here, because a new Java class. I'm going to call this NoDoRoomDatabase. So naming is very important for obvious reasons. So we don't have an option to make this an abstract. I'm going to go with interface for now. I'm going to change in here. So let me say public abstract class like that. All right. The main thing about abstract class is that this can definitely not be instantiated. So we cannot say new NoDoRoomDatabase, which is exactly what we want anyway, because we don't want this to be instantiated at all. And we just want this to be implemented at a class level, just like an interface. And as such, all of the methods inside of an abstract class have to be abstract. So let's go ahead and create all this method that we want. Well, the first thing we want to do, we want to make sure that this indeed extends a room database like that. Click like that, and voila, this is looking very good. And then we're going to make sure that this is a sort of a database type, and we're going to pass in the entities so that it knows exactly that it is connected to our database that we created. So in this case here, what I'm saying is that we need to annotate to make sure this room database belongs to our DAO entity and SQLite at this point, okay? Because it needs that information. So I'm going to say add, say database like that, and we have to pass a few arguments in here. So the first one is going to be entities, as you can see. Let's say entities. So what entities, in this case, is going to say what tables do we need. In fact, because it can be more than one entity, because this is a very simplistic application that we're creating here. But in a bigger application, you would put many entities aka tables. And that's why we put everything inside of Squig to say we can put all sort of other objects there. In this case here, I just have one. So it's going to be NoDo.class. So that is our entity. Remember, our table and our object. And then I'm going to get out of there. Now, if I had another one, I could say comma and say, for instance, another NoDo.class. But this is redundant because we've done that before, right? So if we had another one, we would have done that. So instead, we're going to finish there and put another thing here, which is the version of our entity or database in this case. So I'm going to say version 1. You can put any number you want. So now we know that this abstract NoDoRoom database is indeed connected to this entity here, to NoDo class, and the version of the whole database table is going to be 1. All right. So as we said here, this is very interesting because this room database here needs to obviously have access to our DAO. That makes sense because DAO is what is going to be able to access our SQLite. In fact, this is where all of that insert or all of our CRUD operations live. So the idea of room database is to leverage what we already have. So we need to have an instance of our DAO as an instance variable here. So we need to have a method that would be returning our DAO, which means we'll have access to that, right? So to do that, because we're inside of an abstract class, I'm going to say public has to be an abstract method. It's going to be of our DAO. So let's see what we call it. NoDAO class. There we go. I'm going to call this NoDAO like that. So anytime we call this abstract or implement, override this NoDoDAO, we're going to return the NoDoDAO type. That makes sense. Is this DAO class that we created before, which is where? This one here. So now we have a handle of doing all the things that we want to do. So update, delete all, insert, and so forth. Remember that our NoDoRoom database here, the idea is that it needs to go ahead and get our NoDAO and do all sort of things that it has to do. Mainly, it has to be able to create an instance of our room database because that is what's needed, again, for all of this to work. But this is the actual interface, meaning what connects the DAO SQLite entity all to our outside world, the repository, and ultimately view, model, live data, and user interface. So we're going to create a singleton, remember singleton, so that it's indeed an instance class that only allows for one instance to exist because we don't want to create a lot of room database instances all floating around because remember, this is very expensive, right? It runs a lot of things in the background and we don't want to end up with a lot of memory leaks. So that's why I'm going to create here a singleton. But before we even do that, I'm going to create a private static. I'm going to make it volatile type. So volatile means that whatever variable we're going to create is not going to be cached or saved in any way form. It's going to go directly to the memory so that whenever the memory is out, then that variable is also non-existent anymore. So it's important to use a volatile in this case because we are talking about memory synchronization, making sure that there's no issues beforehand. So you make it volatile so to avoid that instance or that variable to just be wandering around, if you will. Hence the name volatile, something that just flies away when it needs to. So in this case here, I'm going to say NoDo database instance here. I'm going to say is equal to instance like this. So I have this variable, not equal, just get rid of that. Okay, so we have this instance which is going to be a NoDoRoom database, which is our abstract class here, right? So we're going to use that in a second. So next, I'm going to say static NoDoRoom database. I'm going to say get database. So this is where we're going to be able to get database. So it's similar to what you saw before, right? Remember that singleton class we created where we actually create our database and do all sort of things, right? That's what we're doing here. So in this case here, get database, what do we need? Well, I'm going to find a final here, context, because we need that. There we go. And then I'm going to say if instance is null, then I'm going to use synchronize. This is all for UI threads and memory to make sure that things actually work the way they're supposed to work. And I'm going to pass our NoDo room database, that class, because that's what it's needed. And then inside here, I'm going to even say if, to make sure that everything is still updated, right? If instance is null, checking again, then this is where we create our DB. Now, I understand this may be a little bit too advanced for most of us at this point here. If it is too advanced, do not worry. Just know that what we're doing here, we are making sure that we don't run into issues. First of all, creating a singleton instance of our class here. So when we need it, we can actually just go ahead and create our database and not keep creating databases when we don't need it, because it's very expensive. Okay, and so that's where we're going to put our creation there. And then, of course, we have to return our instance. All right, because that's where we said it to be. So let's go ahead and create our DB there. How do we do that? Well, to create our DB, we simply use the instance, because in this case here, we say it's null. We get our instance of NoDoRoomDatabase, right? And then we create a new one. So I'm going to say it's equal to room. This is the first time we actually use the room class from persistence.room, Android there. And I'm going to say room dot database builder. I have to pass our context dot get application context. Okay, we must pass that. Not done yet. I'm going to put comma, new line here. I'm going to then pass here the class that we are talking about, which is our room database, no room database, like that. Say the class and the name of the database. I'm going to call this NoDo_database. Could be any name, that's totally fine. And of course, I'm going to say dot build. There we go. So now we've built our instance, and which is going to be returned. Very cool. It makes sense. Let's look at our diagram here. So what are we doing here? We created DAO. We have SQLite, that's a given. We created our entity. Now our room database is going to be connecting all of these dots, if you will. Right? It's an abstract class because we don't want to go say new room database, because that is very expensive. So we are actually making an abstract, and on top of that, we're making it a singleton because we still don't want it to create different instances of this class, because we should only have one for the entire application life of the application. Anytime we want to create a database, we don't want to go and say new room, build a new one. No, that's not good, because we may have 20 or 30 rooms that we've already created, and that's not a good thing. So we just have one handle here, which we created inside of our room database. So now with this handle, it's going to be able to invoke it to then be able to get the DAO, so data access object, which connects to SQLite and does all of the CRUD operations that we've talked about. All right, so piece by piece, we are getting there. All right, so there we go. We have that. And in the next video, we're going to continue building our very simple, but yet hopefully informative and a little bit challenging Android room application here. All right, I'll see you next.